Christ. All right.
Look at us. We're over here recording. You don't even see us.
History is riddled with unexplained events. You can turn back now or learn the stuff they don't want you to know.
Jasper wrote to us after we were speaking, I guess, about immunology. Is that how you say it, Jasper? That's what it is, I think. You wrote to us with an awesome visualization of some of the things we were talking about. We were talking about antibodies. We were specifically talking about receptors and what an antibody does, how it functions, and then how the immune system within each of our bodies reacts when certain cells are, or certain organisms, let's say, are marked by antibodies. So let's get into this. I'm just going to begin on your second paragraph, just so you're aware, Jasper. You said, so imagine your body is a walled-off city. You have millions of little buildings, these are cells, within your walls, which is your skin, and your immune system patrols the city. And it destroys anything that A, shouldn't be there, or B, has begun breaking down or aged out of usefulness. Makes sense, right? This is me talking. We've got our city, that is our body, and your immune system is the patrol. So, you have an intelligence department, which are B cells, and an operations department, which are T cells. There are some additional special forces mixed in, but B cells and T cells are the most common types in the mix. B, intelligence, T, operations. T cells outnumber B cells by quite a few because they act as the ground troops, right? These are the officers on the ground. The BIA, as Jasper has put it, or the B-cell intelligence agency, is constantly circulating surveillance drones, the things that we call antibodies. It's really interesting to me to think about antibodies as surveillance drones, right? I think that's amazing. So these drones have the ability to perfectly distinguish intruders from residents of your walled-in city. When they find an intruder, they latch onto it, and depending on where they grab the intruder, the drones can either slow it down, incapacitate or neutralize it, or simply stick on it without impacting the intruder's function whatsoever. Here's where the T cells come in, you guys, and this is part of the explanation that really made sense to me. The drones or antibodies act as flags for the immune system. Even if they don't neutralize the threat, as they can sometimes, an antibody helps T cells, the troops on the ground, find the intruder's location. Anything marked with an antibody is destroyed with prejudice, as Jasper says. If it's a virus, the virus is, quote, eaten and chopped up to send around as a way to train the rest of the T cells to recognize that particular bad thing that was found in the body. It also sends it to the B cells, which is, again, the intelligence system, right? So the troops on the ground understand it, and the intelligence system that is sending out signals understands it. If it's a bacteria, it's eaten and chopped up or punctured and, quote, popped or attacked with enzymes and hydrogen peroxide. It's weird to think there's hydrogen peroxide just inside of us, and it's part of our immune system. Ugh. So first of all, guys, just with that explanation, it's the first time I was ever able to really visualize what is going on inside my body. And to be honest, it freaks me out. It seems way more organized and intelligent than I want to give my body credit for, I guess.
Wow, really? We've talked about this idea, though, when you just look at the ratio of bacterial cells to human cells. Your body is much more like a city. We've talked about this in the past, and it applies very, very well.
If your body is a city, are you like the governor of your city, or are you're literally like the infrastructure?
You're like the spirit. You're the spirit of the city. You're your own little Gaia. Yeah, it's like you're the spirit of St. Louis, kind of. But that's like, and I don't want to divert us by getting into too much metaphysical, philosophical stuff, but But you can tell, you can always tell someone knows what they're talking about and is a good communicator when they communicate via analogy. It's one of the best ways to accurately explain concepts that could otherwise be outside someone's realm of expertise. So I just want to say, massive thanks to Jasper. Also, I think your name's very cool. You don't run into a lot of Jaspers these days.
That's right.
In my experience, I don't know.
I don't.
Okay.
Except for you, Jasper. So
Yes.
you continue here, and because we're talking about cancer, which is a really interesting part of the body when it arises, because it's generally cancers. There's so many different types and forms of cancer and specifications, just so many. It's interesting, though, because it is a part of your body that is malforming. It's changing, it's mutating, but it is still your body. So how does your immune system react to it? Well, let's get into that, because you do, Jasper. You say, so if everything is working fine, the B-cell intelligence agency won't be producing any drones or antibodies against any piece of the city that's supposed to be there. If it does, that's the base of an autoimmune disorder. A tumor cell often makes damaged mutated proteins that don't quite match what the BIA recognizes as self, so most tumor cells are killed almost as soon as they form. When a tumor cell's mutated protein slips past the BIA's radar, though, a tumor establishes itself. That's the bad stuff. That's the malignant thing that's going to continue growing. That is no bueno. Jasper, you continue. Most cancer treatments act either like bombs that can destroy any part of the city, or as a shutdown that prevents any part of the city from easily repairing itself. Healthy cells can sort of keep functioning, but they're still prevented from replicating and repairing like normal. Cancer cells that respond to such chemotherapy can't continue to function with that kind of treatment. And here, Jasper, is where you get into that specific strange news story where we were talking about the miraculous 12 people that were cured of colorectal cancer. And we specifically mentioned this thing called PD-1, the protein PD-1. So you talk specifically about this. You say, the monoclonal antibody covered in today's 613 Strange News episode is PD-1 blockade. PD-1 is a protein on a T cell, one of these ground troops. When it connects to PD-L1, which is a protein displayed on some human cells, it tells the T cell not to attack. If a tumor cell can make this protein, then any T cell that tries to come and attack it will instead be told to stand down. It's like knowing the security code or the secret handshake.
Oh yeah, it's cool. It's got somebody's got your back, and they run in and they say, "Hold up, hold up, hold up, hold up, hold up."
Yeah. Yeah. So I'm just going to continue with Jasper really quick, guys. We're almost done here. Jasper says the antibody treatment blocks that interaction, that specific interaction that we just mentioned. Most healthy cells will have a number of other immune checkpoints that prevent the immune system from attacking them, but it's looking like this specific type of rectal cancer doesn't have enough to keep itself disguised. Once it can't maintain the disguise, the immune system recognizes the tumor's rebel forces and goes on the offensive. Because the B cells didn't produce these antibodies, the immune system won't remember how to make these antibodies in the future. They are constantly making random antibody shapes and keep notes of which ones work so they can keep the instructions. God, that's crazy to me. Because they don't have the original notes on how to make the PD-1 antibody, they can't make more, which is probably good. We don't want to permanently hobble all our other cells' white flag functions. That's interesting. White flag functions, as in, like, this one's good. Don't worry about this one.